Hello everybody, today we will discuss about our tools and how to use our tools to solve the vehicle's routing problem. Our team has 6 members and we are 6 funny, attractive and chill guys. First of all, let's look at the overview. We have 4 main parts. The first part is what is the problem the author poses. The second part, which is also the most important part, we will point out objective function, decision variable and constraint. The third part is key points about using R tools, and lastly, how the R tools components relate to the operations research problem being solved. Let's look at the problem posed by Nazanin Morev about minimizing the cost of vehicles in CVRP problem using CP model in 3rd of July 2024. So let's move on to the next part.
So, what is the problem of the author poses? The author aims to solve a capacitated vehicle routing problem, or we can call it CVRP. The goal here is to determine the most efficient routes for a fleet of vehicles with different capacities. We can see here is the code of it. We set up a data named vehicle capacities with the capacities of vehicle 1, 2, 3 respectively. The next goal is deliver goods to customers with specific demands. We set up a data of the demands like the code right here. Altogether, the main goal is to minimize total distance and vehicle cost.
So I'm going to talk about the objective function, the decision variable, and the constraint of this model. So first, we come to the objective function. The main target of the model is to optimize the total distance and the vehicle cost, and that is illustrated by the code below. So next, we come to the decision variable. So we have two binary variable, which is x and vehicle use k. So with x, if the vehicle travel from a location I to j, the result of x will be 1, otherwise will be 0. Same with the vehicle use. If the vehicle is used, the result of it will be 1, and otherwise will be 0. So we have one more accumulate variable, which is u, is to track the total demand on the vehicle after visiting a location. For example, if u equal 5, means that the vehicle carries 5 units of demand after location. So next we come to the constraint. So we have a constraint here, and the first one is the customer visit constraint to ensure that no customer is missed or visit multiple times. The second constraint is depart entry and exit. They ensure that each vehicle can leave the depart at most 1 and return to the depart at most 1. The third one is a flow conservation constraint. It makes sure that each vehicle entering a location must leave the location. The fourth is a vehicle usage constraint. So if a vehicle is used, the corresponding vehicle use k variable is set to 1. The fifth constraint is subtool elimination. It prevents the formation of invalid circles by ensuring a logical flow of nodes. The sixth one is the vehicle capacity constraints. It ensures that the total load carried by each vehicle must not exceed its capacity. The seventh one is demand handling constraint. The cumulative load U at each location must respect the demand and the vehicle capacity. And the last constraint is depart load constraint is to set the depart load to 0. This ensures that no demand is assigned to the depart itself.
So next, let's find out how we use our tools to solve this problem effectively. First, the cost utilize the CBSAT solver. This solver is highly efficient and versatile for solving constraint programming problems. In Python, it's important using from our tools .sat.python imports CB model. Next, we invoke the solver to start the optimization process using solver.solve model. Finally, within the CB model framework, we define 3 critical components such as variable, constraints, and objective function.
So I'm gonna talk about how the auto tool components relate to the operation research problem being solved. The first one is the core Auto2 components. As you can see in the step, is importing the constraint programming satisfaction solver from Google Auto2. CBSAT is well suited for capacitated vehicle routing problems, which is a problem in the forum, due to its ability to handle complex constraints efficiently. About the decision variable, as an example code right here, you can see that the core decision variable x bracket ejk is a boolean variable, which means that it's going to be either true or false. If it's true, then vehicle k going to travel from location I to j, and if it's false, then the result going to be otherwise. About the constraints, as I've researched, I think that the model.add method is the key. It tells Auto2 to add these constraints to the CBSAT model. Then the solver takes care of finding the solution that satisfies all these constraints while minimizing the objective function. The code example in this slide means that each customer is visited exactly once by exactly one vehicle. About the objective function, as you could see an example code right here, model.minimize is mean that is minimize the total distance traveled plus the cost of vehicle use. As you can see the sum in the bracket. So Auto2 allow you to express this as a linear combination of variable. Finally, about the solution extraction, after the solver run, you could extract the solution by using solver.boolean value to check if a vehicle travel between two locations or not, and solver.objective value to get the optimal cost. So that is the end of our presentation. Thank you for listening.